In this unit, we've been reviewing the prerequisite skills you need to be successful in AP Calculus. In this video, let's review how to analyze rational functions. For problem A, ultimately we need to find the domain, and we need to find any holes, horizontal or vertical asymptotes that exist. But before we can do any of that fun stuff, we need to rewrite this in factored form so we can better see what's going on. Let's start with the numerator. So the way I do it, I look at the first term, 4x squared. How can that factor down? This will either be 2x times 2x, or it will be 4x times 1x. Let's start off with 2x times 2x and see what happens. Now I'm going to skip over to the last term of 15. And so that's either going to be 3 times 5 or 1 times 15. Let's start off with 3 times 5. At this point, I always say to myself, inner plus outer equals middle. Here's what I mean by that. Inner would be these two terms right here. If I multiply these together, I'm going to get 6x. So that's inner. When I say outer, I'm talking about these two terms. If I multiply these, that gives me 10x. I can control the signs to be whatever I want. The middle is positive 7x. So I need the inner plus the outer to equal the middle. There's no way to make a 7 out of a 6 and a 10. So this is not working out. Let's try switching the 2x and 2x to x and 4x, because that's the other way it could be. Now this time it matters whether the 3 goes first and the 5 goes second or vice versa. So if this doesn't work, I have one more thing to try. But let's see, inner, I now have 12x, and outer, I have 5x. Remember, I'm shooting for a middle of positive 7. I can get a positive 7 out of this if I make the 12 positive and the 5 negative. That corresponds to a positive here and a negative here. One more thing to check, positive 3 times negative 5 does make negative 15. So we factored the numerator. Let's do the same thing to the denominator. Okay, 8x squared. This is either going to be x times 8x, or it's going to be 2x times 4x. Especially because I see a 4x in the numerator, I'm going to start off by trying 2x times 4x, because in these problems, a lot of times something will match. And in the same way, now I jump over to the third term. This can only be 1 times 5. It does matter which goes first and which goes second. But again, I see the 5 in the numerator, the 4x minus 5. So as a guess, I'm going to start with 1 here and 5 here. Okay, inner plus outer must equal the middle. Inner would be these two. That is 4x. I'm multiplying. Outer would be these two. That's 10x. I'm shooting for a middle of negative 14. Well, I will get negative 14 if both of these are negative. That translates into both of these being negative. And negative 1 times negative 5 is positive 5. So that's it, we factored it. All right, I'm going to do the domain last because the domain really depends on two things. The domain depends on any holes and any vertical asymptotes. So I'm going to need those first. So I'm sure you're noticing that we have this common factor in the numerator and denominator. This is where holes come from. When you have a common factor that will cancel out like this, this is when you're going to get a hole. Okay, and the way you get the whole is by setting this factor equal to 0. So if I take this 4x minus 5 and set it equal to 0, adding 5 to both sides and dividing by 4, we get 5 over 4. So that means there is a whole at x equals 5 over 4. Okay, they're telling us they want the x value and the y value though. So I've got the x value so far. How do I get the y value? Well, we need to use what is left over of the function after we canceled everything out. So we still have f of x equals, which is very much like y equals x plus 3 over 2x minus 1. But now x is 5 over 4. So we're going to have 5 over 4 plus 3 over 2 times 5 over 4 minus 1. We just need to simplify this down. Okay, so let's do like denominators. So in the numerator, I have 5 over 4. Okay, 3 would be the same thing as 12 over 4. Meanwhile, down here, the 2, well, maybe I'll just temporarily write it this way. So multiplying straight across, I've got 10 over 4. And 1 is the same as 4 over 4. Okay, so what happens, man? So that's going to give me 17 over 4. And this is going to give me 6 over 4. All right, but when you divide with fractions, you multiply by the reciprocal. So I'm going to squeeze this in down here. So this is going to be the same thing as 17 over 4 times 4 over 6. Notice that these 4's cancel out, and I'm left with 17 over 6. So we just found the y value. So the whole will be at x equals 5 over 4, and now we have y equals 17 over 6. So as an ordered pair, we can say 5 over 4, comma, 17 over 6. All right, that's the whole. Let's go ahead and talk about vertical asymptotes. Vertical asymptotes are going to come from whatever is in the denominator after you take care of any wholes that you had. So if I want my vertical asymptotes, I need to take the 2x minus 1 and set that equal to 0. So adding 1 and dividing by 2, I get x is equal to 1/2. So that is my vertical asymptote. Okay, let's go ahead and do the domain now. I told you that the domain only depended on any wholes and vertical asymptotes because the domain will be negative infinity to positive infinity, except for we need to skip over any wholes or vertical asymptotes that we have. So we can start off at negative infinity, but when we get to 1/2, we have to skip over that. And when we get to 5 over 4, we have to skip over that. Okay, so 1/2 is first. You know, from left to right, 1/2 is before 5 over 4. So that's why the domain is going to be from negative infinity to 1/2, and then union 1/2 to 5 over 4, union 5/4 to infinity. I just have to skip over the 1/2 and skip over the 5/4. I'm not going to be able to fit all that in this tiny box, so a shorter way of expressing the domain would be to say x cannot equal 1/2, x cannot equal 5/4. So finally, it's time for horizontal asymptotes, if any. All right, for this, I can use the remaining part of the function after we remove the whole. So I'm just going to recopy this over here. So I've got x plus 3 over 2x minus 1. And it is the end behavior that leads to horizontal asymptotes if they exist. If the function approaches a single number, then that's going to be a horizontal asymptote. So let's imagine what happens to this function as x approaches infinity. As x gets bigger and bigger and bigger, in the numerator, only the x term is going to matter. When x is 100 million, the fact that there's a plus 3 here is going to be meaningless. Same thing with the 2x. As this gets bigger and bigger, the -1 is not going to matter at all. So this expression is going to be approaching x over 2x. But this simplifies down to 1/2. So as x approaches infinity, f of x approaches 1/2. So that is the horizontal asymptote. You can easily see that it will be the same deal on the left as x approaches negative infinity, because it'll be the exact same argument. It's still going to approach 1/2. So this is the horizontal asymptote. Of course, horizontal lines are in the form y equals something, so we will call it y equals 1/2. Well, moving on to part B, I see this x in the denominator. This is either going to give me a vertical asymptote at x equals 0, or there's going to be a hole at 0 comma something. I need to see if this x is going to cancel out with an x in the numerator. If the x cancels out, then it's a hole. If it doesn't cancel out, then it's going to give me a vertical asymptote. In this form, it's not easy to tell. So I'm going to go ahead and multiply out everything in the numerator so I can see what's really going on. So let's see, I've got f of x equals 3 times 4 plus x squared means 4 plus x times 4 plus x minus 48. Now I'm going to go ahead and FOIL this, or whatever you want to call it. So I got 16 plus 8x plus x squared, then I distributed the 3, and I got all of this. Notice I have a 48 and then a minus 48. So those cancel each other out. So I'm left with f of x is equal to, and I think I'll rearrange this in standard form. So I've got 3x squared plus 24x all over x. All right, well, here comes the answer to my question. Because this, in the numerator, there's a common factor. The greatest common factor is 3x, actually. So if I factor out a 3x, and then that's going to leave behind x plus 8. But check this out. This x and this x cancel each other out. That tells me that instead of being a vertical asymptote, this is going to lead to a hole. All right, there's going to be a hole at x equals 0. I do need to figure out what the y value is. So right now I know there's going to be a hole at 0 comma something. Now what about the y value? Okay, I think I'll just put it right up here. In order to find the y value, I'm going to use the remaining part of the function. So y will equal 3 times x plus 8. Oh, well, that's it, because the x is gone. So y equals 3 times x plus 8. But x is 0 in this case, so y will equal 3 times 0 plus 8, which is just 3 times 8, which is 24. Okay, so we have x equals 0 and y equals 24. So that's 0 comma 24. So that was my only denominator, and it turned out to be a hole. So there's nothing left for any vertical asymptotes. So there will be no vertical asymptotes. I can go ahead and say the domain now, because it really just depends on the holes and the vertical asymptotes. So I've got this one hole. I'm looking at that x value. So I could say that the domain, if I wanted to say it in interval notation, I just have to skip over this 0. So it would be negative infinity to 0, union 0 to infinity. But a shorter way to say it would be x cannot equal 0. So let's talk about horizontal asymptotes. Now that we have taken out the hole, right? We simplified everything down and we crossed out the x. What we are left with is this. Okay, so I'm just going to recopy that over here. So we're looking at f of x is equal to 3 times x plus 8, which really means f of x is equal to 3x plus 24. I told you that if there are any horizontal asymptotes, they will come from the end behavior. If the end behavior approaches a constant, that will be your horizontal asymptote. But this is just a polynomial. It's really just a line, 3x plus 24. So you know that this is just going to go forever. It's not going to flatten out at a constant. So there will be no horizontal asymptotes. Problem C is going to get very interesting because we have the square root happening. That's going to change things a little bit. We will still start by factoring so we can better see what's going on, including the numerator. So I see there's a common factor of 2. So this will factor as 2 times 3x plus 2. How about the denominator? This trinomial looks like it will factor as a binomial times a binomial. 3x squared can only factor as 3x times x. Jumping over to the 8, that will either be 2 times 4 or 1 times 8. I'm going to try 2 times 4 first. And then at this point, I always say to myself, inner plus outer equals middle. So inner will be these two, so that's 2x. Outer is these two, and that would be 12x. The middle is this negative 10. I control the signs. If I want to get negative 10, I can. I just need this to be a positive 2 and this to be a negative 12. That translates into a positive here and a negative here. Also, positive 2 times negative 4 does make negative 8. So we just factored the denominator. Okay, let's go ahead and deal with the domain actually first this time. We're told to skip over holes. We do need to see about vertical asymptotes, but it will be a little bit more complicated because of the square root. You know that you cannot take the square root of a negative number. That would be imaginary. So in addition to avoiding having a 0 in the denominator, we also have to avoid any negative numbers. So obviously, we can't have 0. So let's figure out what the two values will be that will cause the denominator to be 0. So setting each of these factors equal to 0, let's just do that mentally. Subtracting 2, dividing by 3, we get negative 2/3. So we know that x cannot equal negative 2/3. And of course, adding 4 to both sides, we see that x cannot equal positive 4. So, but that's not enough, because we also have to figure out what values will cause what's inside the radical to be negative, because that's not allowed either. For that, we're going to need a sine chart. So let's make a sine chart over here. These are the critical numbers. So I'm going to put those on my chart. So here is my negative 2/3. And here is my 4. Okay, my two factors are 3x plus 2 and x minus 4. Let's start with the 3x plus 2. Imagine x values in this first interval, something less than 2/3. For example, well, -1. -1 would be less than 2/3. Then we're going to have 3 times -1 plus 2. That would be -3 plus 2, which is a negative number. So that tells me that anything less than -2/3 is going to give me a negative number. Anything greater than 2/3, greater than -2/3. For example, 0. Okay, right in this interval we'd have 0. So 3 times 0 would be 0, and then plus 2 would be 2. So that's going to give me a positive. And that will certainly still be true for things that are bigger than 4. Right? 3 times 4 is 12, plus 2 is 14. So anything bigger than -2/3 is going to give us a positive number. What about the factor of x minus 4? Well, clearly, if x is equal to 4, that's right when the 0 happens. So any number that is bigger than 4, for example, 5, right? 5 minus 4 is 1. That's a positive number. Anything bigger than 4 is going to give you a positive number. Anything less than 4, for example, 3, is going to give you a negative number. So we would have a negative in this interval and this interval. But under this radical, these two factors are being multiplied together. So in the first interval, from -infinity to -2/3, we have a negative times a negative, which is a positive. In the second interval, we have a positive times a negative, which is a negative. And in the third interval, we have a positive times a positive, which is a positive. So remember, the issue is we cannot take the square root of a negative number. So this middle interval is the bad one. We can't have a negative number. But the first two intervals are okay. So that will be our domain. It's going to be okay from -infinity to -2/3, And then it'll be okay again from 4 to infinity, because that's where everything will be positive under the radical. Okay, so let me see if I can just squeeze this in small. So I'm going to have negative infinity to negative 2/3 union 4 to infinity. So there's my domain. We still need to find the vertical asymptotes if there are any, but it's a little bit hard to see what's going on. I'm noticing that we have this common factor of 3x plus 2, and I'm tempted to maybe cancel these out or something, except for the fact that one of them is under a radical, so you can't just cancel them out. So what can we do? Let's rewrite this using exponents. We know that square root is the same thing as the 1/2 power. So I'm going to rewrite f of x. In the numerator, I will still have my 2 times 3x plus 2. But in the denominator, where I have the square root, I will have 3x plus 2 to the 1/2 power times x minus 4 to the 1/2 power. Now I can deal with these common factors, because when you are dividing, you subtract the exponents. In the numerator, the exponent is 1. So I can divide these. I just need to subtract 1 minus 1/2, which will give me 1/2. So this will be the same thing as f of x equals 2 times 3x plus 2 to the 1/2 power. And in the denominator, we still have our x minus 4 to the 1/2 power. So we still have a vertical asymptote. If I were to set this denominator equal to 0 and solve, because that's where vertical asymptotes come from, setting the denominator equal to 0. So I would get x minus 4. Let's go ahead and put this back at square root. So we have the square root of x minus 4 equals 0. Then I would square both sides, so I get x minus 4 is equal to 0. And then I add 4 to both sides, and I get x is equal to 4. So that is my vertical asymptote.